Okay, so reviewing from yesterday real quickly. Okay, we talked about scalar quantities and vector quantities. Okay, and we talked about how they can tell kind of the same story, but from different points of view. If we're dealing with vector quantities, direction matters. Okay, I have to be concerned with whether something went north or south, okay, or up or down. Whereas with a scalar quantity, I don't care which way it went, just how far, how fast, okay, or how long. Okay, that's all I care about for those. Direction isn't important for scalar quantities. Now, this question was our first example of a question that involved vectors. It involved that direction was important, okay, and it consists of two parts. So what I have to realize to start it off is that the average velocity, velocity being a vector quantity, is equal to the total displacement of the object, the total displacement over the whole trip, okay, divided by the total time. All right, and we said that for this trip, the bus travels 100 kilometers north and then travels 62 kilometers south. Okay, so from a vector perspective, I don't get all the way back to my starting point. I am displaced this far from my starting point at the end of the trip. Everybody follow me on that? Okay, can I figure out from this information how far that is? Yeah. Okay, then I'll have the total displacement for the whole trip. The other thing I need is the total time for the whole trip. And can I find that? All right, so what we want to do here is break this up into the two parts, just so we have the givens written down for each part. Okay, so part one and part two. Okay, so in part one, we know that the displacement is 100 kilometers north. Okay, in part two, we know the displacement is 62 kilometers south. All right, part one takes 1.2 hours. And part two takes 0.9 hours. Okay, if I need the total displacement and the total time, I can find that now. Okay, so our average velocity will be 100 kilometers north plus 62 kilometers south, or just subtract, whichever makes more sense to you. Okay, I'm making the 62 south negative because it's opposite north. Everybody all right with that? Okay. And then I'm going to add the times together. 1.2 hours plus 0.9 hours. Okay, so what I'm going to end up with is that my total displacement is 38 kilometers north. Okay, because that's how much short of getting all the way back I end up. Everybody follow me there? Okay, don't be afraid to ask questions, guys, if you're not following me. All right, and then my total time, it took 1.2 hours to go forward, it took 0.9 hours to go back, which means the whole trip took 2.1 hours. All right, now I have my total displacement and my total time, so I can calculate what my average velocity is, which will be 18.1 kilometers per hour north. Okay, so anytime you have a trip that has more than one part, that's what you're going to have to do. You're going to have to find the totals. Now, a second part of this question might ask this. What is the average speed over the whole trip? Okay, how is what I just did there going to change if I want to calculate the average speed? Okay, is speed vector or scalar? It's scalar, right? It doesn't care whether I went north or south. Okay, so as a result then, okay, so speed, that's the v without the arrow over top, is going to be total distance, that's the d with no arrow, divided by total time. I already know the total time, it's the same. Okay, it's 2.1 hours, so I don't have to do anything new there. Distance is scalar, so it doesn't care whether I went north or south. So how far did I go? I went 100 north and I went 62 south. How far did I go? 162 kilometers, okay? This one, direction doesn't matter, okay? So I take the 100 and I add the 62, right? Because that's how far I went, 162 kilometers. Oop, works better when it's on. Okay, so my speed is 77 kilometers an hour when my velocity was only 38 kilometers per hour north. Okay, because it only took into account that limited little amount there, or 18.1, sorry, that limited little amount at the end, whereas this took in the total distance. Okay, so that's where vectors and scalars look at the same story from different points of view. Okay. All right, questions on what we did there? We're going to spend lots of time on that, so if we don't get it right now, okay, there's more time to figure it out. All right, so things to remember here. Scalar quantities have magnitude only, okay? So distance, 65 kilometers. Mass is scalar, 75 kilograms, okay? Like when someone asks me what my mass is, I don't tell them. But if I did tell them, okay, I wouldn't say 75 kilograms down, okay? Mass doesn't have a direction. It's how much of me there is, okay? It's how much matter I possess. It doesn't have direction, okay? Time, 4 days. Okay, time doesn't have a vector. Okay, it's how long something takes. Right, vector quantities, things like displacement, like velocity. Okay, we talked about these formulas here. Okay, v equals d over t. Speed is distance over time. Okay, v equals d over t with the arrows. That's velocity is displacement over time. And if we're talking about averages, it's total over total. Okay, for both. All right, I want you guys to try that one. Simpler than the one we just did. Okay? A deer runs 100 meters in 20 seconds. How fast is it going? Okay, so this one's pretty straightforward. Okay, 100 meters. What did they give me? Distance, right? Because they didn't say 100 meters north. That would have been a displacement. Okay, they just said 100 meters. Right, and they told me 20 seconds. So that's a time. How fast is it going? Am I looking for velocity or speed? Speed, because if they wanted velocity, they would have said how fast and in what direction are they going. Okay, I would have done that differently. I can't solve for velocity here because nothing had a direction on it anywhere in this question. Okay, so v equals d over t, so simply it's 100 over 20. Okay, and that's going to be 5 meters per second. All right, that's about as simple as they get. Okay, because obviously you didn't have to manipulate the formula at all there. Okay, just had to plug in. Okay, for this one here, okay, it's asking how long something will take. So what am I looking for in this one? Time. Okay, so like I always do, guys, with a new formula, I'm going to show you all the manipulations here. Okay, so in this one here, time is what we're looking for. Okay, we're moving at 330 meters per second, so that's a speed. Okay, and we're traveling 400 kilometers. That's a distance because again, no directions were given in this one. All right, so v equals d divided by t, and I'm looking for t. Remembering that I can't solve for something if it is on the bottom of an equation. So I need to multiply both sides by t, and then divide both sides by v. All right, so I'm going to end up with t equals d divided by v, and then I just plug in my numbers. D was 400 meters, v was 330 meters per second. Okay. All right, so it would take 1.2 seconds, okay, for it to do that. All right. Everybody all right with that one? Yep. Oh, 400 kilometers. Sorry, good eye. So that's not going to be right. What do I have to change the 400 to? Meters. I can't divide kilometers by meters per second. So how many meters in a kilometer? 1,000, yeah. So 400,000 meters. Okay. All right, so it's going to take 1,212 seconds for that to happen. Okay. All right, questions on example 2. Okay. Last thing is, okay, we're looking for, again, time here. I don't know why I have another one for time, but okay. So it travels, you guys try this one. It travels 650 meters north at a velocity of 9 meters per second north. Okay, how long is it flying? Give me a minute on that one. So for this one, it gives me vector quantities, but then asks me to solve for time, which is scalar. Okay, so even though it gives me direction, the directions aren't really important because they're actually going to cancel off here. Okay, so it tells me the displacement is 650 meters north. Okay, the velocity is 9 meters per second north, and we're looking for time. Okay, so again, when we manipulate, v equals d over t for time. Time comes over here. Okay, speed comes over here, and we get t equals d over v. Well, that's going to be 650 meters north divided by 9 meters per second north. The norths essentially cancel, okay? The meters cancel, and I'm left with seconds, okay? 650 over 9. Okay, so 72 seconds is how long that thing's going to fly for. All right. Questions on that one? Okay, so this one's a good example of a question that is going to ask for both vector and scalar stuff, kind of like what we did with the bus question a few minutes ago. All right, so the elevator travels up 85 meters in 30 seconds and then travels 60 meters down in 20 seconds. We're looking for the average speed as well as the average velocity. All right, so the calculations here are going to be similar, but there's going to be slight difference between them. All right, so think back to the bus question and then try and do this one. I'll give you a couple minutes. Okay, so in the bus question, okay, I'm not going to do the whole thing here, but I'll give you some tips for starting it. Okay, in the bus question, we said that we want to break this up into the two parts. Okay, so in the first part, the elevator is going up. Okay, it travels upwards 85 meters, right, and that takes 30 seconds. Okay, and then in the second part, okay, it goes a displacement of 60 meters down, and that takes 20 seconds. Okay, so now we should be able to figure out what we're doing here in terms of average speed. Remember that average speed is total distance over total time. Okay, and average velocity is total displacement over total time. Okay, keep those in mind. This up. Okay, so for part A, we're looking for the average speed. Is speed scalar or vector? Scalar. All right, so it doesn't matter whether I went up or down. I just need to know how far the elevator went in total. Okay, so the total distance is 85 plus 60, which is 145 meters. The total time is 30 plus 20, which is 50 seconds. Okay, so 145 divided by 50 okay, is 2.9 meters per second. Again, no direction on that because that's speed and it's a scalar quantity, right? What's different for part B is now I'm asked to find a vector quantity. I went up 85 and down 60, which means I'm displaced from my starting point how far? 25 meters. Okay, so to do that, I go V equals essentially 85 minus 60 over the total time, which is still 50 seconds. All right, so we're going to have 25 over 50. Okay, and that's going to be 0.5 meters per second. But what do I need on this? The vector quantity. I need a direction. What is the direction? Up. Right. Okay, if you didn't have up, would you get that right? You would not. Okay, it's a vector quantity. It has to have a vector. All right. Questions on that one? Okay. Now, this takes it another level. This trip has 3 parts. Still the same idea. Okay, still the same idea. Write the different parts down, but it has 3 parts instead of 2. All right. So write this one down because it's a good example. Okay, and see if we can figure it out. It does give you different information this time. The last few have said, here's the displacement, here's the time. This one gives you some velocities. Okay, so it gives you a little bit different information. Okay, remember, in the end, we are still dealing with, okay, these formulas here. Average velocity is total displacement divided by total time. Okay, and average speed is total distance over total time. Okay, give you a few minutes on that one. Get it written down and give it a try. Oh, thanks. Okay, so we want to write down first off what happens in each part of the trip. Okay, so in part one, okay, they travel or they walk for 1.1 hours. So t is 1.1 hours. Okay, at a velocity of 3 meters per second north. Okay, in the second part, okay, they walk 7 kilometers south. So, sorry, displacement, 7.0 kilometers south. Okay, and they do that in 1.5 hours. Okay, and then in the third part, they walk at 4.5 meters per second. Or, sorry, part three. Okay, 4.5 meters per second north for 2 hours. All right, so there's what we know. Okay, now what I see a lot of people do with this question is they start thinking about how they've been taught to find like average velocity or like the average of anything in their whole life, which is I add up them all and then divide by the number I had, right? So like if I wanted to calculate the class average in here, I'd add all your marks together and I divide by the number of students, okay? And so what they do is they find the velocity for part two and then they go 3 plus whatever that is plus 4.5 and divide by 3, okay? What's wrong with that? Well, for one thing, they're not all in the same direction. And secondly, they don't all represent equal parts of the trip. Okay? If I want to find the class average, you all represent equal parts of the class. Okay? But in this case, okay, some of these parts of the trip are much longer than others. Like this one's only 1.1 hours, where this one is 2. Okay? It's quite a bit longer. It represents more of the total. I have to weight it that way. Otherwise, it would be like me saying, I traveled to Edmonton, and for 300 kilometers of the 310 kilometers, I traveled at 120. But the last 10 kilometers, there was construction, and I had to slow down to 50. So I'll add the 120 plus 50 and divide by 2. Is that going to give me an accurate representation of what my average velocity was over the whole trip? No, that's like saying for half the trip I went 50 and the other half I went 120. Well, it certainly wasn't half and half. It was like 98% and a little bit more, okay, and 2% for the end. I can't just add them together and treat them like they're equal. Everybody okay with that? All right. So we want to find the overall distance traveled first, okay? Well, if I'm going to find that, I need to know how far they went in part 1 and also how far they went in part 3. But I have a problem. My time's in hours. My speed's in meters per second. So do those units match? They don't. Okay, so what I should probably do then is convert the hours into seconds. Easier to convert that than this. Okay, so what do I multiply by? 60. Okay, so that's the first step. So 1.1 times 60. Okay, that's 66 minutes, but I need to go to seconds, so I got to multiply by 60 again. I could shortcut that and just multiply by 3,600 also. Okay, we'll do that next time. Okay, so yes, 60 is 60 times 66, something else. Okay, 3,960 seconds. Okay. All right, so now I can calculate how far in meters now this part of the trip is. So I'll take V times T, that's the manipulation, okay, and go 3,960 times 3. All right, so they're going to walk 11.8 kilometers, 11.88 kilometers, but we'll put it in meters, 11,880 meters. Okay, and that is north. I also have to have that. Okay, in part 2, I already have distance and time. Don't need to find anything there. I don't have distance for part 3. It's the same calculation as I did in part 1. Distance equals, or sorry, displacement equals velocity times time, right? I've got to put the hours into seconds. So 2 times 3,600 is 7,200 seconds. Okay, so 4.5 times 7,200 will give me my distance, or displacement, sorry, in meters. So 4.5 times 7,200. All right, so they go 32,400 meters. And that's north because that's the direction they were going. And then this one here, I'm just going to quickly convert this to meters as well, okay, just so that I have it in meters too. All right. Does distance care whether we're in north or south? No. So what do I do with all 3 of my D's? Just add them up, right? Okay, I don't care whether they're north or south, I just add them up. So I take my 32,400, I add that to 7,000 and to 11,880. All right, so the total distance the elephants walked is 51,280 meters, or 51 kilometers. Okay, so they walked a long way, but they're big. Okay. All right, the second part is it wants to know the average velocity of the elephants. Do I want distance or displacement to calculate that? Displacement. All right, so now direction matters. Okay, so for this last part, average velocity is going to be the total displacement divided by the total time. Okay, so that's going to mean positive 11,880. I'm going to make north positive. Okay, minus 7,000 because that was south. Okay, plus 32,400. Right, so this one's north, that one's north, so I made them positive, okay, and I subtracted the one that was south. I also need the total time, okay, so we've got 3,960 seconds plus 1.5 hours, so I got to convert that. All right, so 5,400. And the other one is 7,200. Okay, so how come I didn't make the time for part 2 negative? Right, I don't go back in time by going south. Okay, so I can't make it negative. It doesn't take time off, okay, to go south. All right, so when I do this calculation, okay, I'm going to have on the top 11,880 minus 7,000 plus 32,400 divided by the bottom, okay, which is 3,960 plus 5,400 plus 7,200. All right, so the average velocity of the elephants is 2.25 meters per second. And because it came out positive, it's which direction? North. Okay, that's about as tricky as a v equals d over t problem would get for you. Okay, they won't get any harder than that. All right, questions on what we did there? Everybody all right with that one? Okay. In your workbook, I want you to try a few of these problems just to get some good practice with them here. Okay, so we need the physics worksheet package. Okay, so that's in the About tab on Google Classroom. All right, and it'll be the first page. Okay. So these start out quite a bit easier than what we just did. Okay, they're just simply v equals d over t questions. All right, so just give those a try. The answers are in bold, so you can see if you did them right. Okay, so we've got this bus trip, and it travels 11 kilometers with a average velocity of 21 meters per second. So that's part one. Okay, so in part one, we have a distance of 11 kilometers, okay, and I should say speed of 21 meters per second. Okay, and then in part two, okay, it travels only 1 kilometer, and it does that at a smaller speed of 4.2 meters per second. All right, I'm going to want to turn these kilometers into meters so that they match the fact that my velocities are also measured in meters. Okay, so these are going to be 11,000 and 1,000 meters each. All right, so what's the average velocity of the bus over the entire trip? Well, if I'm going to find average speed, sorry, in this case, okay, that's a typo there. Average speed is going to be total distance over total time. Well, I don't have the times for either part, do I? But can I find the time for both parts? Yeah, okay. I'm just going to manipulate v equals d over t to solve for t. So I'm going to bring t over here, bring v back under. All right, so t equals d over v. So 11,000 divided by 21. Oop. All right, so 523.8 seconds. Okay, and then I got to do the same thing over here. I'm going to go 1,000 meters divided by 4.2. All right, so that's going to be 238.1 seconds. All right, now I've got distance for each part, time for each part. Now I can do this calculation. So my average speed will be 12,000 meters, because that's how far I went in total, divided by 523.8 plus 238.1. Okay, so when I punch those in, I should get an average speed of 15.8 meters per second north. Okay. Any other ones giving us trouble? Okay, keep going. There's still a few minutes left in class. Okay, shouldn't see anybody packing up.